All right, again, we're going to factor this completely. I personally always find when there's a negative out front, it makes it harder to factor. If I took a negative out of the whole thing, that would change the top to this. And then maybe it'll be easier to factor. So once again, nothing cancels out, so we're not going to have any holes. So the first thing we're going to do is draw our vertical asymptote at x equals 1. If we consider the highest degree in this one is an x squared, if we look at the highest degrees, we have a minus 2x squared on the top, and we have no x squareds on the bottom, and this is not possible because you can't divide by 0. This is telling us that we're going to have an oblique asymptote. And so we use synthetic division to find out what our oblique asymptote. We're dividing by x minus 1, so we put a 1 there. Our original equation was minus 2 plus 5 minus 2. Minus 2 plus 5 minus 2. Bring the number down, multiply, add, multiply, add. And what our expression says here in the end is minus 2x plus 3 remainder negative 1 is the answer after we divide. And that will tell us that minus 2x plus 3 is our oblique asymptote. The remainder itself doesn't matter if it was a remainder 2 million. The asymptote would still be whatever it is. Yes, Ernest? Yeah, that would be a plus 1. I just hadn't taken the time yet to put that in. Yeah. And it doesn't matter if it was minus 1 or plus 1, you would still get the same asymptote. Good adding. Excellent. So now I'll go back to my graph. Here at 3 is the y-intercept. A slope of minus 2 means down 2 over 1, down 2 over 1. Y equals minus 2x plus 3 is our other asymptote. So now we're going to graph our x-intercepts and y-intercepts to see if we have enough points to graph the whole thing or if we have to find another point. Finding a y-intercept, if you plug in 0 for x's, this would be 0, this would be 0, this would be 0, and you'd be left with negative 2 over negative 1, which is just 2. So we know that 0, 2 is our y-intercept. And we already factored it. So we'll be able to find out what our x-intercepts are. We know that we have one x-intercept at 1/2. And we have another x-intercept at 2. Since you have points on the left side of the vertical asymptote and on the right side of the vertical asymptote, we can just finish this graph going towards the asymptotes. Yeah, it doesn't matter what the oblique one is, because once you get one on the right side of this x equals 1. It's either going to be in this little section below, and then you'll know what the graph looks like because it's got to go to that asymptotes, or it's going to be in this section where it was, and then you can just draw it towards the asymptotes. So we're not looking, in these sketches, we're looking for the general shape, and once you have one point and those asymptotes, you just draw it towards the asymptotes, and that gets the general shape. And the question for this one is question number 5.